Hi everyone, today I am going to show you how to build a drone with all the standard autopilot functions using PorcupineRC Ground Station. All the functions are integrated into this SRX8 receiver, which is similar to the SRX7, but this one has a built-in micro Sparky 2 flight controller inside. We will just need to plug in the cam, GPS module, and the ESCs for driving the motors, all directly to this receiver. And then we will need to do some simple settings in the Ground Station app and do some configurations in Autopilot Mission Planner software through the USB port here. And then I will replace this low-cost camera with an HD video recording module and take some videos in HD. Let's go through the whole process now. First of all, we need a drone frame. There are so many choices of drone configuration you can choose from in Autopilot. SRX8 has 6 motor outputs from the built-in flight controller, and it also has 2 direct servo outputs, so you can choose any drone frames with up to 6 motors. Then we install the base mount of the GPS module. The module needs to be raised up to keep it away from the noise generated by the high current wires and ESCs that will affect the GPS signals and the secondary compass inside the module. Next, let's install the camera. Our receivers are compatible with PAL and NTSC video signals. The camera is connected to the receiver with 3 wires. They are 5-volt, ground, and video signal. Then we solder the brushless motors to the ESCs. You may refer to Autopilot website to get to know the motor spinning directions for your drone configuration. You can exchange any 2 out of 3 wires in order to reverse the spinning. Next, install the motors to the frame and fix the ESCs in positions with zip ties. It's time to stick the ground station receiver to the frame. You need to stick it close to the center and use high temperature foam tape because the video transmitter inside the receiver will generate heat. Next, we can plug the motor control wires to the receiver according to the motor configurations of Autopilot. The output port named M1 to M6 are actually the motor ports of built-in micro Sparky 2 flight controller. Now we stick the GPS module to the mount. And we can also plug in the connectors of the module and the cam to the receiver. Then we secure the antennas with zip ties. We can roll up the cable without making any sharp corners. If the antenna or antenna cable are damaged, it will damage the 2.4 GHz front-end IC, and you will find something wrong with the data link quality number in the app. Now we wire up the battery power to all the ESCs and receiver. I do it by soldering all the black wires together and all the red wires together. You don't need any power supply module or UBEC for our receiver. It has its own standalone power management system. It draws power directly from the battery, detects the battery voltage level, regulates the voltage internally for camera, GPS module, and flight controller. By default, it doesn't deliver 5-volt voltage to the servo ports like the regular receivers do, unless you connect the V pin to any of the middle pins of the servo ports. We've completed the drone assembly. It's time to connect the phone to the S6 ground station. Now we connect the phone to the S6 ground station. Plug in the Type-C USB cable to the ground station through this hole. The plug and the cable will be hid inside the handle to avoid being touched by the pilot during the flight. Before I start the app, I will first bind the receiver to the ground station. Here is the binding procedure. First, turn off the ground station, and before connecting the battery to the drone, insert this bind plug to the channel 8 servo port. Then we connect the battery. Now the receiver is in binding mode. You should see the communication LED is solid on. It's waiting for binding message. Now we turn on the ground station. The LED starts flashing slowly. That means it has successfully bounded to the ground station, and from now on it will listen to and respond to this ground station only. Then we disconnect the battery and take away the bind plug, then connect the battery again. Now the brightness of the LED represents the data receiving quality. The higher the data communication successful rate, the brighter it will be. Now it's time to turn on the ground station app. Choose your email address that you used to buy your ground station. Allow the app to communicate with the ground station and USB camera. If you don't see the second message about the USB camera, it is because the FPV switch is off. And if you really don't need the FPV function, you should turn it off. to save battery, and the ground station will run much longer. Now we have a quick look. The numbers at the bottom left corner are data link quality and video signal strength. You can change video channel with the upper buttons here, and the video channel frequency is displayed at the bottom center here. Next, create a new model for this project. We need a default 4 channels model to start with, and give it a model name. Then, go to Switch Config page. As this ground station has no hardware stick, so we choose on-screen sticks. And I am a right-hand throttle guy, so I choose Mode 1. And I want the throttle stick goes back to the bottom automatically whenever my finger is off from the screen. So I choose throttle spring bottom. This is what I want for safety when I do all the tuning for the drone. I will change the throttle spring to none when I demonstrate GPS position hold with my hands off. Now we connect the SRX8 receiver to Mission Planner. You can still connect the receiver to Mission Planner without plugging in the battery, but the USB will only supply power to the internal flight controller board, so the GPS module will have no power without the battery connected. Now we connect the SRX8 receiver to Mission Planner. You can see that it doesn't recognize the GPS module yet, so we go to Configuration, Full Parameter List, and search for the word serial. The port on this side of the receiver named GPS is actually the serial one of the R2 Pilot. So we look for parameter serial 1 protocol and set it to 5. That means GPS. And set the serial 1 bulk weight to 38. You can see the definitions here in this column. And set the serial 3 protocol to -1. And click Write Parameter. This serial 3 is actually the port here on the other side, named main port. And this is unused port for this project, and you can use it for other hardware or sensors that R2 Pilot supports. Do not plug the GPS module to this port, as it will automatically configure the GPS module. But we don't want it because the GPS module is also used by the ground station. It needs its own GPS messages. Now we search for the word GPS. Look for the parameter GPS type and set it to 2. And look for GPS auto config parameter and set it to 0 to disable auto config for GPS module. Next, search for BATT and look for parameter battery monitor and set it to 3. This will enable the battery voltage detection. Now we need to reboot the flight controller. Unplug the battery and USB cable. Then plug the battery back in first before the USB cable. Connect to the Mission Planner again. On the main page, the GPS status is now become no fix. That means it has GPS module, but just don't have enough satellite in view. So it's working normally, and you have to go outdoor to get GPS fix. And it is showing the drone battery level, but the voltage is not yet correct. So we go to Full Parameter List and search for BATT again. Look for parameter battery voltage multiplier and set it to 11. And battery voltage pin should be 12, so we just leave it unchanged. Now GPS and battery detection work fine. We go to status type to see if there are 2 magnetic field readings. You can see here Mag field and Mag field 2 have readings. That means both internal and external compasses are working normally. And obviously the internal gyro sensors are working normally too, but they have not been calibrated yet. Now go to Initial Setup, Mandatory Hardware, Radio Calibration, and check if the radio communication is working normally or not. Now we go to Frame Type, select X-type quadcopter. The SRX8 receiver has 6 motor outputs from the built-in flight controller, named M1 to M6, so you can choose a frame type with up to 6 motors. Next, let's calibrate the accelerometers. Simply follow the instructions. Place the drone level, click down, then left, then right, nose down, nose up, and upside down. Then we put the drone in level again and click Calibrate Level. Now we go to Compass. The compass number 1 is the external compass inside the GPS module if it is connected. Otherwise, compass number 1 is the internal compass if there is no external compass connected. So we check externally mounted for compass 1. Now click Start and rotate the drone along all the axes until both Mach 1 and Mach 2 bars are full. You should do this process away from any source of magnetic disturbances, or you may need to do this process again outdoor later. Now we configure the radio channels in the Ground Station app. Let's add the 3-way button switch and assign it to channel 5. It will be used to control the flight mode. I want the flight mode buttons located at the upper left corner of the screen, and it is where switch E located. Enable it. Change the switch name to Mode. Switch type is 3-way button. The buttons appears on the screen here, and now go to Advanced Mixing. Simply assign Mode to channel 5. We can go to Output page to check how the channel 5 is working in response to the buttons we just added. Next, we do radio calibration. In Mission Planner, click Calibrate Radio. Just follow the instructions carefully. Click OK and move all RC sticks and switches to their extreme positions. Now we can configure failsafe issues. We are going to configure radio failsafe and low battery failsafe. Go to failsafe, set low battery failsafe to 11.1 volt. Select RTL. That means the drone will automatically return to where it took off if the battery voltage is lower than 11.1 volt. For radio failsafe, the default throttle value to trigger radio failsafe is 975, which is lower than the expected minimum throttle value. We can leave it unchanged, but we need to configure the receiver so that it will output a throttle value lower than 975 when it doesn't receive radio signal from the ground station. In the Ground Station app, go to Subtrim Reverse page. Adjust the lower endpoint value of channel 3 to 950 temporarily, which is lower than 975. And you can see from the Mission Planner, the radio failsafe has been triggered immediately. Now we can tell the receiver these are the permanent failsafe values it needs to remember. We do it by simply holding the failsafe button of the ground station for more than 10 seconds. Look at the COM LED of the receiver. When the failsafe setting is success, the COM LED will be off for few seconds. Radio communication will be lost during these few seconds, and communication will come back when it's done. Now adjust the channel 3 minimum endpoint value back to 1000. And try to turn off the ground station and see if the failsafe is triggered. It works. Now turn it back on. This time we close the app without switching off the ground station. Failsafe will also be triggered in a situation like the phone is out of battery or the USB cable is unplugged accidentally. Next, we need to do some configurations for different flight modes. With channel 5, you can assign up to 6 flight modes to the flight controller, and now we use only 3. You may adjust the endpoint of channel 5 to match the PWM range for each flight mode if necessary. Now, I assign the top button to Return to Launch, the middle button to GPS Position Hold, which is called Loiter, and the bottom as Stabilize mode, which is basically manual mode with basic stabilization and auto leveling. Next, we go to Full Parameter List. Make a search for ARM. Look for a parameter arming check. Check only barometer, compass, RC channels, and battery level, and uncheck everything else. If you can't fly manual mode, you should check GPS Lock 2. Then, set the arming volt minimum to 10.5 or whatever value that suits your project. With a battery voltage lower than this value, you can't arm the flight controller at all. Save the changes. Then, make a search for LOG. Find the parameter Lock Bit Mask and uncheck all. Since the built-in Micro Sparky 2 flight controller is a simplified version and it doesn't have SD card slot for logging the data, Finally, for the autopilot we are using, the RC pitch needs to be reversed for correct operation. You may either reverse it in Mission Planner or reverse it in the Ground Station app by checking the reverse box of Channel 2 in Subtrim Reverse page. Now it is ready for a test flight. Now I have connected the drone to the Mission Planner and I have calibrated the compasses one more time outdoor and away from all kinds of magnetic disturbances. And we now have 11 GPS satellites, although we are now in between a lot of tall buildings. And we have 3D fix and the color of EKF is turned to white. It was red when we configured the flight controller indoor. Now everything looks good. Let's start tuning the drone performance. First, we need to arm the flight controller. To do it, we need to switch the mode to stabilization mode. Make sure the throttle is at the lowest level. Then move the yaw stick to the rightmost position and hold it for few seconds. You will see the red LED of the flight controller change to solid on when it is armed. Let's try to fly it with default sensitivity value. You can see that the drone wobbles a lot. When you see this, connect the drone to the Mission Planner again. Tune down the sensitivity value until the wobbling goes away. In the app, you can see that the distance from home is about 12,000 kilometers. It is just because we haven't set the home location yet. Just go to Home Setting page, select Set via Aircraft to set the home location as the current location of the drone. If your home location will be moving, for example, if you are on a cruise ship or on a yacht, you can select Keep Tracking My Location and the app will use your cell phone location as your home location for the Ground Station app. By the way, now the Go Home arrow will point to the direction to fly back home relative to the moving direction of your drone. And it will consider your drone location is at home if it is within 10 meters from the home location. Even if it is 3D, you can still use loiter mode for tuning the drone. And there is auto tune function you can use too. Now we can try auto takeoff, GPS position hold and auto landing. You need to arm the drone in stabilization mode and switch to loiter mode. Later we will go to open space and fly it with more accurate GPS location fix. Since I am now in between tall buildings, so you may see it is drifting a bit. Now we have finished the first stage of the project, which is building a drone with FPV function and all the standard autopilot functions using PorcupineRC Ground Station and SRX8 receiver, which has built-in flight controller supporting autopilot firmware. As long as it can do GPS position hold, it can also do return to launch, altitude hold, circle mode, auto mode for planned missions, as well as many other autopilot functions. We will demonstrate some of those functions in open area, but we will first replace the low-cost camera with another camera with HD video recording functions. Now we land the drone in loiter mode. All cameras with PAL or NTSC outputs are compatible with PorcupineRC Ground Station receiver. There is a video buffer in the receiver to make it compatible with all PAL or NTSC cameras in the market. This camera I'm going to put on the drone has 1080 resolution, 60 frames per second. There are 4K cameras with compatible output in the market at higher price. Whatever camera you use, it is connected to the receiver with only 3 wires. They are Vivo, ground and video wire. Some camera in the market has PWM control input, and you can wire it to channel 7 or channel 8 of the SRX8 receiver, so you can take aerial photos or videos with the buttons of the ground station. I split the flight mode button switch into 2 sets of buttons to control channel 5 with advanced mixing function for easier mode switching. One button is for activating or deactivating stabilization mode. If the button is in non-stabilization status, it will be either in loiter mode or return to launch mode, and it is determined by another switch. I also configured channel 9 as the arming channel. By using advanced mixing function, pilots have to use 2 fingers to arm or disarm the drone for safety. Also, I added one more button switch as landing switch and assigned it to channel 10 for auto landing. Here is how it works with these settings. Use 2 fingers to arm the drone with the lowest throttle level and in stabilization mode. Then switch it to loiter mode and take off. The drone holds its position in strong wind condition. Now we try to land with the landing switch. We have finished the drone project with autopilot functions using S6 ground station and SRX8 receiver with built-in flight controller. There are lots of other functions in the ground station system I haven't mentioned, as well as in the built-in open source flight controller. For more details, please go to PorcupineRC website.